Welcome to the channel. Our motto: to facilitate students in learning physics at their convenience. So it is a class without a classroom. Learn physics at your convenience. Let us start our today's lesson. The topic is lens equation or lens formula. Before starting the derivation of lens equation, let us discuss the three special rays that we use for geometrical construction of images formed by a convex or concave lens or formed by a spherical lens. Students, look at the diagram. Here is a convex lens shown and there is an object O placed in front of this lens. There are three rays that we have assumed. Ray number 1. Any ray that is coming parallel to the principal axis, after passing from the lens, it will always pass from principal focus. We named it ray number 1. Ray number 2 is our ray that is passing from optical center of a lens. It will pass straight without changing its path. We named it ray number 2. Ray number 3 is a ray that is coming from principal focus. After passing through the lens, it becomes parallel to the principal axis and we named it ray number 3. Students, any two of these three rays can be used for geometrical construction of image formed by a lens. Now let us start the derivation of lens equation. Again, consider a convex lens in front of which an object AB is placed. Using these two special rays or using ray diagram, A prime B prime is its image. F is the focal length, O is the optical center, and X is a point that we have assumed here. Look at this diagram. There are two triangles, OAB, triangle OAB, and triangle OA prime B prime. These two triangles are similar. How they are similar? Look at these. These two angles are same, and these two angles are also of 90 degree. They are also same. So these two triangles are similar. You know, if triangles are similar, the ratio of their two sides is equal to the ratio of their two other sides. Here we take the ratios of their perpendicular. AB ratio A prime B prime, it should equal to this distance divided by this distance, ratio of the two other sides. Similarly, students, there are two other triangles named as FXO and FA prime B prime. Again, these two triangles are similar. These two angles are of 90 degree and these two angles are also same. Again, taking the ratio of the two sides. Now look here. The distance OX is equal to the distance AB, being the distances between two parallel lines. So these two are same. Either we can take OX or we can take AB. It does not matter. So here I take AB ratio A prime B prime, perpendicular of this triangle, ratio perpendicular of this triangle should equal to base of this triangle OF divided by base of this triangle. So these two ratios are same. Now comparing these two equations, since their left hand sides are same, therefore their right hand side should also be equal. Right hand side of this equation is equal to right hand side of this equation. Now students, FB prime has no specific name in the diagram. So we replace it. FB prime equals to OB prime. What we did? OB prime, this total distance, and we subtracted this OF, this distance, from this total distance. So we obtained this distance by subtracting this smaller distance with this larger distance. Replacing the value of FB here, the equation gets this form. OB over OB prime equal to OF over OB prime minus OF. Now giving these distances specific names. What are those names? Putting BO. BO is the distance of object and I represent it with P. You may represent it with U or any other letter as you like. But here I represent this distance of object with P. FO is the distance of principal focus from optical center. By definition, it is called focal length. So I represent it with small f. Third one is OB prime, the distance of image from the optical center or distance of image. I represent it with Q. So in this equation, we replace these distances by these symbols and we get the equation P by Q equals to F over Q minus F. It is the same equation, only notations are changed. Now look at this equation. What you will do to solve it? We will just cross multiply it. This side is multiplied with this and this is multiplied with this. What we get? PQ minus PF equals to QF. To solve this equation, dividing both sides by PQF. This will be the situation. This term is divided by PQF. This term is divided by PQF, and right hand side is divided by PQF. Some of the terms will cancel each other. PQ in the first term is cancelled with PQ. PF in the second term is cancelled with PF. QF in the third term is cancelled. What we are left with? 1 over F minus 1 over Q is equal to 1 over P. Now we will just rearrange it and we will get the standard form of Lenz's formula or Lenz's equation. 1 over F equals to 1 over P plus 1 over Q. F is the focal length. Its value is positive for convex lens and its value is negative for concave lens. P, distance of image. Value of P will be positive for all real images. And Q is the real objects. P is the distance of object and value of P will be positive for all real objects. Q is the distance of image and value of Q is positive for real image and Q is negative for virtual image. Students, a virtual image is one that we cannot obtain on the screen, where the rays of light do not actually meet, but they appears to be meeting there. So this image is virtual, its value will be negative. Students, this is all about the lens formula, how it is derived using ray diagram. I hope it is clear. Students, thank you for sparing your time to watch the video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.